Hello everyone, here in this section we have tangent planes and differentials. Definition: the tangent plane to the level surface f of x, y, z equal to c of a differentiable function f at the point p naught, where the gradient is not zero, is a plane through p naught, normal to gradient of f at this point p naught. The normal line of the surface at p naught is a line through p naught parallel to gradient of f at this point p naught. Tangent plane to f of x, y, z equal to c at p naught. So here we have x naught, y naught, z naught. Here is partial derivative of f with respect to x of p naught multiply x minus x naught plus partial derivative of f with respect to y of p naught multiply y minus y naught plus partial derivative of f with respect to z of p naught times z minus z naught equal to 0. And normal line to f of x, y, z equal to c at p naught, which is x naught, y naught, z naught. Here we have x equal to x naught plus partial derivative of f with respect to x of p naught times t. Y is equal to y naught plus partial derivative of f with respect to y of p naught times t. And z is equal to z naught plus partial derivative of f with respect to z of p naught times t. Example: find the tangent plane and normal line of the level surface f of x, y, z equal to x squared plus y squared plus z minus 9 equal to 0 at the point p naught 1, 2, 4. So this is what we have for this example, the tangent plane and normal line to this level surface at p naught. The tangent plane is the plane to p naught perpendicular to the gradient of f at p naught. So here we have the gradient equal to, here we have 2x times I plus 2y times j plus 1 times k. At this point 1, 2, 4. So here we have 2 times 1 times I. Then we have 2 times y. So y is 2. We have 4j. And then we have 1 times k. So here we have 2i plus 4j plus k based on this point. So the tangent plane is therefore the plane 2 times. Then we have x minus x naught, which is 1, plus here we have 4 times y minus y naught, it is 2, plus here we have 1, so 1 times z minus z naught, it is 4 equal to 0. So simplify, here we have 2x plus 4y plus z equal to 14. And the line normal to the surface at p naught is x equal to 1 plus 2t. So based on this point that we have here we have 1, 2, 4, and based on what we have here on this part, we have 2 times c, which is this one. And then we have 4 times t. And then here we have 1 times t, so it's coefficient of z. So x is 1 plus 2t, y is equal to 2 plus 4t, and z equal to 4 plus t. Plane tangent to a surface z equal to f of xy at x naught, y naught, f of x naught, y naught. The plane tangent to the surface z equal to f of xy of a differentiable function f at the point p naught, which is x naught, y naught, z naught, is equal to x naught, y naught, f of x naught, y naught is partial derivative of f with respect to x of x naught, y naught times x minus x naught plus partial derivative of f with respect to y of x naught, y naught times y minus y naught minus z minus z naught equal to 0. Find the plane tangent to a surface is equal to x times cosine of y minus y times e to the x at the origin. So here we have f of xy equals to x cosine of y minus y times e to the x. So first, we will find partial derivative of f with respect to x. Here we have x, y, so it is this point, 0, 0. This is equal to, so partial derivative of f with respect to x, here is cosine y minus y times e to the x at this point, 0, 0. This is equal to cosine 0, it is 1, minus y, it is 0, times e power 0. So this is equal to 1 minus 0 times 1, and this is equal to 1. And partial derivative of f with respect to y at this point, it is equal to, here we have cosine y, so it is negative sine y times x minus, what we have for this part, partial derivative with respect to y, it is minus e to the x at this point, 0, 0, so this is equal to, we have negative 0 times sine 0, so it is 0 minus e power 0, so it is 0 minus 1, that is equal to negative 1. So the tangent plane is based on what we have here, partial derivative of f with respect to x, that is 1. So we have 1 times, then we have x minus x naught, so x minus 0. Then we have partial derivative of f with respect to y, it is negative 1 times y minus y naught, so y minus y naught, it is 0. Then we have minus z naught, and z naught, it is 0, so this is equal to 0. Or, so simplify what we have here is x minus y minus z equal to 0.